Ask My Instructor 6.6.29. A trough has a trapezoidal cross-section with a height of 7 meters and horizontal sides of width 3.5 meters and 7 meters. Assume the length of the trough is 11 meters. How much work is required to pump the water out of the trough to the level of the top of the trough when it is full? There's a number of things we're going to need in order to find how much work is required to pump the water to the level surface. One thing we need is the density of water, which is 1,000 kilograms per cubic meter. We also need to know the force of gravity that we're going to be acting against, 9.8 meters per second squared. In addition to that, we're going to need to know what is the area of a rectangle formed by slicing the trough lengthwise at height y. We're going to have y range from 0 to 7. 7, recall, is the height of the trough. So y being 0 would be the bottom, y equals 7 would be the top. And at a given y value, if we make a slice lengthwise, we will get a rectangle, and we need to know the area of that rectangle. The last thing that we're going to need is the distance that the slice has to travel to reach the top of the trough. So we're going to be making lots of slices of this trough, and the slices will be lengthwise. And each of those slices have to travel up to the top. And for each slice, the distance will be different, as will the area of the slice. The first thing I'd like to work on is the area of the slice. Well, the length, if I'm cutting it lengthwise, the length is 11 meters. What is the width at a given height of y? To find that, I'm going to use a little bit of maneuvering here. I'm going to put my x-axis at the bottom of the trough. Now that's essential because I've already stated that y is running from 0 to 7. So y equals 0 is the bottom of the trough, y equals 7 is the top. Now the y-axis, that's the one that you can play with. I find it easiest to put the y-axis right in the middle. Now once I do that, I can use the information given me to find 2 points of that one side of the trough, the right hand side of the trough. I find 2 points. Once I find those 2 points, I can find the slope of that pink line. And you'll see in a minute why I want to do that. But for right now, what is the slope of that pink line? After you find the slope of the line, use the slope and use one of the points. I'm going to use the bottom point in order to find the equation of the line. So I just use the point slope form for the equation of a line, and then I clean it up. The equation of that line is y equals 4x minus 7. Now I'm going to do something that may seem a little strange. I'm going to solve for x. And this is what I get. Now why did I do that? X is half the width. That green line that we're looking for the length of that width, x is half of that width. And so twice of x, for a given value of y, twice of x will be the width of the green line. So I multiply that expression by 2, and I get that my width is half of the y plus 7. And so now I have the area of my rectangle. I'm going to multiply that 11 times 0.5, and I'll get 5.5 when I do that. Now that I have found the area of my rectangle, I'd like to know how far does it have to travel to reach the top of the trough. Now, it's important to know where it's traveling. If it's traveling to a point above the trough, I would have to account for that. But in this problem, it's just going to the top of the trough. And so the distance it has to travel is 7 minus y. I've set up the problem so that y runs from 0 to 7, so that'll be the bounds on my integral. I have also found a of y, the area of my rectangle. I have found d of y, the distance the rectangle has to travel. I know what the density of water is, and I know what the force of gravity is. So right now, I just plug everything into my integral. And this is what I get. Next, I'm going to bring the rho, the g, and the 5.5. I'm going to bring it all outside of the integral. And I'm also going to multiply y plus 7 times 7 minus y. And that's what I get. Once I do that, it's fairly straightforward to integrate. And then after I integrate, I'm ready to evaluate. After I evaluate, I'm ready to put in the values for rho and g. And this is what I get for work. I have given you the exact answer and also an approximation where it's rounded to the nearest whole number. And that's how many joules it will take to empty this trough up to the surface of the trough.